Welcome to another Great Cow Basic presentation. I'm going to be looking at assembler three ways. I'll explain. The methods are shown here on the left. Just use Great Cloud Basic syntax. It creates portable code. It's very optimized for your chip and configuration. I'll talk about that. That means that if you have a delay, depending on what chip it is and what the configuration is and the frequency, the delay will always be the same delay. You get self-documenting code, and it's pretty simple to use. But however, it may use more instructions than raw assembler. It does. It absolutely does because of that portability. You can just insert commands. I've shown you that. We're going to go through that in a moment. It leverages the Great Cloud Basic memory, and it's self-documented. But it does use, but your method might use less memory, which is great. But it is going to create a chip-specific solution. You're in the realms of the ASM will only work on one chip family. Won't work. You can't go from AVR to PIC, LGT, etc. And all the timing and timers need to be managed. So if you change the frequency, then you're going to have to go back in and do all that. And that's not a problem because you're pretty good at doing that. Then you might want to use an ASM. Just put ASM as lead in there. Well, you can do that because it does allow you a wider range of instructions, but you can still use Great Cloud Basics logic like labels, go-tos, etc. Great. So you can actually mix and match here. It uses less progmem, chip family specific, timings. It doesn't support the Great Cloud Basic memory management. You're going to have to start handling that on your own. And then there's raw ASM. Well, it permits the full range of ASM instructions, but it will just assemble it blindly. It doesn't really care. So what I'm going to show you is I'm going to show you just how very quickly these three in use. Okay, so Great Cloud Basic, some raw ASM as a lead, and then hash raw ASM. So what have I got out in the lab? I've got trusty old Q41 LED flashing. It's great. All right, so we're going to go straight into the editor and we're going to have a look at what we're going to be doing now. Okay, let me just bring up the baseline. I'm just going to bring up some cameras, etc., etc. Great, there we go. So what I've got is some code, some base code. This is Great Cloud Basic. I'm just going to assemble that up and put it inside that chip. Okay, all right, and it will program it. You'll see it flash up, and it programs it. Wonderful. So what we've got is an LED that's flashing, and I can create the same code, and I can put in Mega 328. Okay, Mega 328p. I can't assemble it. Well, I'm going to assemble it, sorry, but I can't program it because it's my fault. I'll change it to a 10F or something like that. I could change it to other chips. Okay, all right. Now I've got PIC-AS loaded, so it's just telling me I can't create PIC-AS for the Mega, but that's the way it is. So I've got a baseline piece of code, okay, that is using Great Cloud Basic, and it's generating assembler. If I press F7, you can see the assembler here, and it's wonderful. It's pretty good. It's fully documented, and it is using raw assembler. So that's the generic. So let's have a look at some assembler. Let's have a look at a baseline piece of code, okay? And then what we're going to do is use this baseline to show you how it works. So I've got a piece of program here that's going to rotate the LED. I'll just put that straight into that chip, and it's going to set a variable called display. It's then going to rotate it every 197 milliseconds, and it's going to rotate it exactly as it is there. Well, we can look, and the important thing about this is that this code has taken 66 words, okay? 66 words of program code and 1 byte of RAM, okay? Portable code, I can come in and I can change the frequency at the top here. I can put 64 in here, and that will still do that at 197 milliseconds. It's portable code, okay? So I could do that across many different chips, and it will work very, very well. So let me have a look how we're going to do that, because that's ASM. There is ASM in the background. You can take that ASM. If I show you the assembler, you can take that assembler and you can play with that to your heart's content, and you can take that through MP-ASMX to compile if you want to, or MPLab or PIC-AS. You could take it either way, but it is assembler. Let's look at the same code, but starting to use ASM. So I'm putting ASM source inside of my code here. Look, I've got Clear the register, set the display variable to 8. And you can see I've got this piece of code called ASM at the front, and I'm actually putting assembler inside of here. I'm doing it this way because I want to use some of the go-tos, etc. within here. Now you could use go-to as ASM as a prefix, but I'm not. I'm just going to show you that before, if you remember, that was a number of words. I'm just going to compile that up, and you'll see that the code is operating exactly the same, because I made sure it was this morning. That has used 52 words. So clearly something in Great Car Basic is not optimized, and that optimization comes at is in the delay function. When you say wait, in our original source here, wait 197 milliseconds, it's a generic piece of code because it takes care of your chip, your frequency, and other parameters. Because you can put wait 10 days, 1 microsecond. It's a utility function, therefore it uses more words. But once you've done it once, you've done it once. But in this assembler, our delay is coming from this loop here, which is going to delay it by 197 milliseconds. And if I change the frequency of that chip, the delay is no longer valid. But I'm using Great Car Basic variables. I've defined them called display. I've got another one called delay, and I'm having to initialize them because I'm using ASM, ASM as my prefix. The assembler is documented, exactly what you've done. It's no different. And you've defined the variables in memory. Works well. Let's look at the third option. Third option is hash raw ASM. Well, I can compile it up and it will go in. And I can type in any assembler with the prefix of hash ASM raw, and it works. You can see it's programmed it. And however, the source is now not documented because we have no idea what you're doing. So we just pass the raw ASM straight through. It is this code, by the way, has gone through PIC-AS, so I know it's valid. All right. So, and you can see I've had to use constants from my memory management. You have to do all the memory management. You're on your own with that. You still get to use the config management of Great Car Basic and the initialization of the oscillator, etc. Okay, but we are now down to 32 words. So the balance in what I'm showing you is there are 3 ways, and that balance is portability, simplicity, through to the utility of using ASM versus hash raw ASM, okay, which is very specific, and you need a high level of skill, because the first option, the Great Car Basic, being simple, you don't need a lot of skill. But these 3 methods work very well, and I just wanted to take you through what they do. So you can just use the basic instructions. You can use ASM or use raw ASM in your code. That's what I wanted to show you. So do enjoy using assembler with Great Car Basic.